The insurance sector has evolved over the last decade quite a bit. It started from only paper-based conclusions of insurance policies. You got paper-based certificates sent out, and it's even used today a lot. But then also it evolved already a bit, so you can already find some applications that you can use to sign up for contracts, so it becomes more dynamic and more individual. But that's not the end, so it's going even further, and maybe in the future we look at completely machine-to-machine business in the industry industry for all, or the Internet of Things. So you could, for example, imagine a cargo container that is ensuring the freight automatically without any human interference. And for the more dynamic part, for the future part, you need a lot more trust, you need a lot more proof. And for this, we have built EverContract, which is distributed ledger-based, to actually give you that trust. And if you look at the insurance ecosystem, it's very diverse, so that's perfect for a distributed ledger. So if you put a distributed ledger in the middle, all of those participants can actually profit. You get a single source of truth, you get a very high efficiency across the whole value chain, and also you have no media disruption, which you would get if you have just paper-based contracts or PDF. Now, why don't we just use classic smart contracts? Let's look at how they are implemented. Now, if you look at the blockchain implementation, it always has an immutable part, and it has the actual blockchain implementation. And on the immutable part, the smart contract is stored data plus code. And this has a huge advantage, which is that the execution is immutable and unstoppable. That's great. But there's also a huge disadvantage of that, and that is that the execution is immutable and unstoppable. And the reason is that you must actually not base contracts on their execution. That's a fundamental thing of most legal systems in the world, because it contradicts the implied covenant of good faith and fair dealing. So the human interpretation is what actually counts, not the execution of the contract. And that's a big problem for complex contracts. But also, a disadvantage is that it's written in code. So it can only be read by programmers. So you could ask, is it really smart? And is it even a contract? Now, the way we implemented it is we are using a non-proprietary standard, which is called iXperience, that has been developed over the last almost 20 years. It's very mature. And with that, we can define extensible Ricardian contracts. And those Ricardian contracts are human-readable and machine-readable. So we define this contract, and then inside of that contract, you can actually tag the information that's in there, which then can be read by machines. It is also readable by non-programmers, which is very important. It looks like a common legal contract. You can print it, put it side by side to a real contract, and you will see absolutely no difference. It's machine readable because it has this tagged data that can be read. And the most important thing is not proprietary. So there are already a lot of tools out there to work with this. Now here's an example that you have seen earlier. And what you can also do with this standard is that you can actually automatically validate that contract. So you can check the dates in there, you can check the address, you can check if things add up, if there's a summation in there. And also, we are allowing a very fine granular access of the data that's in there. So we have a standard API that looks like actually SQL. You can say, give me the premium of policy XYZ, and you get the premium. You don't have to load the whole contract for that. So it gives you fine granular access to the actual data, which helps you integrate into existing systems. Now, what about extensibility? If a contract gets stored on one node, it gets validated and then distributed across the ledger. On the other nodes, there can be a completely different validation. That's the extensibility. For example, if you validate an address, you can check the syntax of that address. you can check that the address exists, and you can also check if the person actually lives at that address. So there are different levels of validity checks, which depends on the background of the information that you have. And also, there's a privacy issue. So not all of the nodes in the distributed ledgers should be able to read every information. So we allow that by using private channels in that ledger. And let's look at how extensible Ricardian contracts are actually implemented. Because here's the blockchain implementation. Again, you have the immutable part and the blockchain implementation. And on the immutable part, we store the data, the legal prose, and some declarative code which needs to be interpreted. So we strip away the execution from the immutable part and put it on the actual blockchain implementation, which is the interpretation of the code. This allows real separation of concerns, and so even a court can interfere again, and that's more like the real world. The implementation is based on Hyperledger, and here's the quote from Joy Ito. He said, blockchain will be to banking and law what the internet was to media. It's a great statement, because I love this comparison to the internet, and I would like to stretch it even a bit more. Because before, the predecessor of the internet was something called BTX. That's what's used also in Switzerland. And in the US, it was called ARPANET, and this wasn't very successful. And then they started to make it decentralized, and they put a standard on top of the protocol stack, which was actually HTML. And then the internet took really off, because it became very broadly applicable for many use cases, and the data was accessible. And that's exactly what we are doing here. We have the protocol stack, which is blockchain, and we put a standard on top. So blockchain without standardized data is like the internet without HTML. So let's put standardized data on blockchain and stop putting proprietary data on blockchain to make it accessible, interoperable, and the holy grail of insurance. Thank you.
Okay.
All right,
I'll take the remote.
Yeah.
With even 30 seconds to spare, who's got a question first? Yes, we'll go to you, Matthias.
So you're saying that existing smart contracts, they are not able to capture the complexity of life insurance or insurance policies?
Yes, that's what I'm saying, yes.
Been clarified.
That's one part of it, I mean, yeah.
Christian?
So you mentioned that recurring contracts are there since 20 years. So, but I do not know so much companies which are using it. Do you have any idea why?
So it's not Ricardian contracts are there for 20 years. It's the standard that's there for 20 years. Ricardian contracts are less. It's still very hard to work with it. You need to have the expertise, which we have. So you should work with us, and then you're fine. So.
That's a good answer. All right, Vasily?
So I think you made a great argument about closed systems and how people actually benefit from an open ecosystem. But at the same time, you base your solution on Hyperledger, right? And Hyperledger is a private network, right? And you need to have people agree to run Hyperledger, right? So if they run something like Quorum or Corda or Ethereum, they are missing out, right? So I think that's a big problem. So how easy is it for you to pivot to support Solidity, for example, and how do you deal with that problem?
I think it's just possible to do that, and we haven't fixed that yet, or we haven't implemented that yet, but I think it's possible. And I mean, not putting standardized data is also not a solution, right? So it's better to take the standardized data, whether it's on Hyperledger or on Ethereum. So I don't have a favorite.
There's a follow-up here.
So then, I would really like to challenge your choice of Hyperledger, right? Because even though Hyperledger does have a new functionality in version 1.0 to have the private channels, the private channel mechanism is really non-flexible, right? Because in reality, in real world, when companies deal with contracts, they have many-to-many relationships, and these relationships change, and depending on the constellation or counterparties to a particular contract, you will need, actually lots and lots of different channels.
Yes.
To cater to that problem, and it's a known problem in existing, Hyperledger implementation. So how do you deal with that? Because moving information between the channels actually breaks the decentralization aspect and the trust aspect.
Just go and pause you there. Do you have a response to that?
I have, yes, if you
Real
allow
quick,
that.
15 seconds, go for it.
Okay, so yeah, but in the end, it's something that also evolves, right? For now, it's enough for us, but it will not be enough in 10 years. But also the technology improves, so we just count on that.
All right, thank you so much. Have a seat.
Thank you.